been part of the industry for 25 years now. First as an engineer, inventor, and then CEO, and now the Stratasys chairman and chief innovation officer. So looking back, I can say that it's been a very exciting ride. Looking forward, I can see a massive expansion in new manufacturing applications. I've seen the term 3D printing progress from a little known term to a household name, and now we're additive manufacturing and direct digital manufacturing solutions are commonly accepted in many manufacturing places. Most of the world knows what 3D printing is and is quickly learning its capabilities. This new awareness is accelerating the adoption of 3D printing, both for product development as well as for manufacturing. I'm going to focus more on manufacturing today. With all the media attention, both realistic as well as a little bit of hype, we all now have a big expectation placed on us. I believe that we'll meet most of the expectations, but possibly in unexpected ways. I believe that 3D printing for production is now taking off and fundamentally changing manufacturing as we know it. Now, is it going to happen overnight? No. Is it going to be a total disruption? No. And is it going to change as predicted? Also, probably not. There are those that embrace the technology and believe the grand visions that are being promoted. Others kind of push back and cite the technology limitations, the cultural barriers, and the unrealistic benefits. The believers in overnight upheaval kind of gloss over some of the hurdles. The skeptics focus on what we hold as truths today, as opposed to looking out and seeing how the technology and the applications will change. For the overnight upheaval believers, there's really no yardstick. There's no performance measure to consider. And for the skeptics, the success of 3D printing and manufacturing is really hindered by its inability to meet today's performance standards. The skeptics compare 3D printing to traditional manufacturing, focusing on the limitations rather than its huge advantage. And I think, like the skeptics, I don't believe that 3D printing success lies in replacing traditional manufacturing. I actually believe that the success comes from expanding manufacturing offering, doing manufacturing differently, offering more tools for the right job, and leveraging what makes 3D printing unique. There's sort of a bit of wisdom in the prototyping side and the prototyping history that foretells, I think, the future in manufacturing. Today, 3D printing for prototyping is accepted, it's ordinary, and it's necessary. But when we go back to where we started in our garage, it wasn't accepted. I got thrown out of a lot of early on engineering offices because it was too far out. But I think in that beginning, the skeptics wrote it off because it was inferior to conventional practices. And at the same time, the hype was proclaiming that 3D printing would replace CNC machining. But really, neither of those predictions proved true. For manufacturing applications, 3D printing is where prototyping was about 15 years ago. Steadily gaining acceptance, but still a lot of resistance. A lot of big predictions and still kind of finding its way. But over time, as was true in the prototyping applications, I believe it'll be widely used as a tool that complements as opposed to replaces traditional molding, machining, casting, and fabricating. So based on based on the past experience, I believe that manufacturing applications using additive manufacturing, which is about 15 years now in evolution, will see significant adoption, coupled with new technologies as well as new materials, getting new strengths and understanding how they work in the material as it comes out of the systems. So growth will rise sharply, I think in the 5 to 10-year time frame. And it's in this phase that we'll see new practices becoming embedded in our manufacturing culture. There are two simultaneous trends in additive manufacturing occurring today. One is personal manufacturing, and the other is industrial manufacturing, where performance is critical. Perhaps the greatest asset of 3D printing is that it's an enabler. It enables the user, and this is true for the individual as well as the corporation. Yet it's most obvious for the individual who lacks the skill, the experience, and the right tools for the job. Giving a consumer a tool that requires no prior skill and a few, if any, complementary tools to replace nearly and to replicate nearly any form, that's a game changer. And I think we're all part of a major change that's going on, enabling non-technical, non-engineers to be able to produce pretty much any shape. 3D printing enables them to make something where previously they could not. It's a tool that lets them release their creative or technical talents and then bring their ideas to life. For personal gratification or personal need, individuals are printing art pieces, jewelry, novelties, and replacement parts. It doesn't matter really if the piece is an ornamental or functional, organic or geometric, raw or painted. It is, by the very definition, in-use part manufacturing. As long as the intent is to use it or perhaps sell it, but not validate, the consumer is now manufacturing. So, in a sense, manufacturing has actually already reached the home. What I find most exciting is the role that 3D printing is playing, modifying consumer behavior through the new ecosystem that's that it's been given life to. Individuals can acquire new, unique items from a much larger pool of options, and those with creative talents have access to hundreds of thousands of consumers in this way. So I'm speaking of online destinations like Thingiverse, a MakerBot digital content sharing site, or maybe Shapeways, for example. Creators no longer have to battle for valuable shelf space or seek seed capital to start the manufacturing. These are really transformative times that we're in, and that's one of the factors that prompted the Stratasys to merge with MakerBot. The other driving factors were its leadership role in low-cost, entry-level 3D printers, online sales channel, and its consumer-oriented retail structure. We've witnessed that low-cost options are wanted in the home, in the schools, and also in business. So while consumer market as a growth, I think will be very big, I believe that industrial manufacturing will be much bigger. But to properly address manufacturing applications, I need to break the conversation really into two segments: augmented manufacturing and alternative manufacturing. Now, augmented manufacturing is where 3D printing makes the tools that are used in manufacturing, like for instance jigs and fixtures. Alternative manufacturing as well, the 3D printer makes the actual in-use part. And I'm going to go ahead and start with augmented manufacturing because really very few talk about it. With all the media coverage in 3D printing for consumer and for manufacturing, the focus has been on in-use items or custom or series part production. However, that spotlight has left the most common manufacturing applications really in the shadows. I want to take a few minutes and shine the light on augmented manufacturing because it's a proven solution that can decrease time as well as cost while improving your quality and capabilities. It's also a solution that anyone can implement now. The solutions and the quality outputs are available now. You're really unlikely to read about augmented manufacturing in the mainstream because it really isn't, it's not sexy for the mainstream media. It doesn't have the awe component of a story, such as printing a jet engine part. I'm talking about all of those manufacturing aids scattered across your production floor. You know, the jigs, the fixtures, the organizers, the shields, guides, and the templates. Using your 3D printer, you can make those low risk, potentially high reward items. You can do it right now, put them into service tomorrow, and this can be done directly by the production engineer. Consider what goes into machining a fixture, that whole process, or a 5S organizer, and compare that with the ease of use, simplicity, speed of 3D printing. And that's why it makes sense. It makes a lot of sense. Some companies are just starting to save time and money with 3D printing of jigs and fixtures. Others, like BMW, have been at it for 10 years. BMW doesn't simply replace machining. It redesigns for performance, since 3D printing builds complexity without cost. I think I got out of sequence here with my PowerPoint, but that's okay. The fixture allows for placing in a precise way, easy way, the rear name badge, and it reduces fatigue and cycle time through ergonomic design, and it ensures repeatability and quality. So now if you do the math, in many cases, 1.5 million vehicles, saving a few seconds, a few minutes, times the hourly wage. Many times you can drop $100,000 to the bottom line, and that's on a per fixture basis. So as these applications grow, the only barrier really on the applications is no longer the CAD, it's no longer the output or the materials or the accuracy. It's now really just getting the word out because it's too mundane for the media to report. So while augmented manufacturing is overlooked by the mainstream media, all the attention is put on part production, in-use parts. So as an alternative approach to custom or series part production, 3D printing is very real, and there's a growing belief and acceptance in these solutions. The opportunity is real when it's matched with what 3D printing delivers, or in some cases, when traditional manufacturing just can't deliver what the geometry of, let's say, a 3D printer can. The skeptics are correct when held to the same standards as traditional manufacturing for certain characteristics, like, for instance, surface finish or material selection. 3D printing is not going to be equal. Looking at it this way, though, it sort of devalues its benefits. With the skeptics line of thinking, in fact, if you think about it, investment casting should have vanished a long time ago. Compared to machine parts, it's got a narrower material selection, poor accuracy, definitely inferior surface finish, yet it remains a staple because it offers things that machining can't do. So 3D printing's opportunities and its growth will come from those applications where the traditional methods are no longer practical, and 3D printing is a more efficient process. 3D printing's growth is really somewhat dependent on technology advancement, but equally dependent on discovering the applications where the value overshadows any perceived limitations. So in this area, the media attention has been a boon. It has companies pondering the question of how and where to use 3D printing. It has startups employing new business models, and it has a product manager considering new markets. So something as basic as this cell phone cover is a perfect example of recognizing what 3D printing can do, and it's an example of its value overshadowing limitations. In a single operation, 3D printing can make this cover with moving gears, and we make these by the hundreds. If this was your project, it's likely that the value of eliminating 7 molds, 7 injection molding operations, an assembly step, all the overhead that goes into stocking 7 parts in inventory really trumps any technology limitations. And never forget that 3D printing for production is not just about plastic parts. Direct metals and printed electronics are 2 very interesting applications. Both are poised for phenomenal growth, and both deliver unmatched values when compared to traditional manufacturing. Another item that skeptics fail to recognize is that many companies already opt not to use traditional mass production processes. For instance, when they have not enough volume to warrant a tool, and for those, 3D printing is not competing with injection molding. For example, take the case of Kelly Manufacturing, which makes aircraft instrumentation. Its production volumes are really too low, and the product changes too frequent to justify investments in injection molding. For one part, a instrument housing, its preferred production method was urethane casting, in other words, in rubber tooling. By switching to FDM, it accelerated production by 27 days, reduced the part cost, and improved part quality. And now if Kelly decides to redesign the housing, there's not going to be any cost or time penalties to put the new design into production. You basically press the button and get that out. So is production via 3D printing worth consideration? Well, Jeff Emmett, the General Electric Chairman and CEO, thinks so. When discussing 3D printing for production of the fuel nozzle on its LEAP jet engine, he commented, it's worth my time and a lot of investment. Mark Little, the GE's CTO, went on to say it's really fundamentally changing the way that we're thinking about the company. While we have many customers doing in-use parts with their own FDM printers, we see far more applications on a daily basis through our Red-Eye digital manufacturing service. And most of them actually would never make the headlines in the media, and the reason is because many times we're making components for products that the average person doesn't even know exists. They're internal. Maybe it's a feed bezel for a pill dispensing machine, an internal bracket for a food processing piece of equipment, or a housing very deep within an industrial product. So of course those stories lack the sort of the wow factor compared to a GE jet engine or a NASA mission. The stories don't make the cover of The Economist, but these stories are unfolding today, and they're evident that 3D printing is for production and it's very real. And that brings me to a few words of caution. The headlines, whether you embrace them or whether you reject them, are not really able to and not really presenting a full story. So you could be missing out or caught off guard. 3D printing is growing all around us at a fairly rapid rate, but much more silently, I think, than you'd think. It very well could be a sort of a quiet revolution in the use of direct digital manufacturing that sneaks up on us. One of the growth drivers of 3D printing is increasing the use in education. In the late 90s, it was said that 3D printing had to be placed in education to sort of nurture students on the technology. But at that time, it was a big challenge because the system prices started at $60,000 per system. But with a steady reduction in the entry-level system prices, it's really become a reality. Today, 3D printers are in primary and secondary schools, and it's a commonplace, very similar to CAD as it's gone into the school systems. And this has two advantages. First, every student exposed to 3D printing will go into the workforce with the expectation that it's available and understands when and also how to use it. But I think also, secondly, it also inspires kids to consider coursework in careers in science, in technology, engineering, and math, or in other words, STEM, at the same time, it's not uncommon to, we basically need to encourage the students more and more and give more access, as well as more applications and more purposes using 3D printing. So, as it's done for STEM, 3D printing can put manufacturing in a different and in an engaging light, helping to rid of the stigma of manufacturing being a dirty process, repetitive work being possibly avoided for the student for their career. But maybe the answer is to revive the shop classes in the past, but with a focus that includes 3D printing. At a recent FIRST robotics competition, the kids were 3 deep around the printers, fully engaged. They came rushing to make parts, either replacement for broken parts or redesigns for their robots that they're working on. these students were discovering what 3D printing can do for manufacturing without actually realizing that they were manufacturing parts. I'll bet that each of those students would graduate with the expectation that the tools will be available to them, so that then when they enter the workforce, the students will be a catalyst for growth and adoption. They'll enter their careers not with a focus on what 3D printing can't do relative to traditional processes, but instead with an appreciation for what 3D printing can do. What isn't a given in a appreciation for the design using 3D printing is the element of design for manufacturing. So design for manufacturing today, I think, is a university level or a trade school level concept, but it's very much needed. We need to support that more. I think we're underperforming in the area, and we need more basically design for manufacturing criteria relative to additive, relative to 3D printing. Well, so in closing, I believe that we're in very exciting times, and that 3D printing will enable significant changes in the way that we buy and the way that we make the products that we want to need. That process will impact consumers, prototypers, manufacturers, and educators. But remember that this may be a quiet revolution where progress and innovation is happening quickly, but outside of view. Good applications may be too mundane, and some companies may avoid the public spotlight to maintain their competitive edge. But I think the group here should try as much as possible to show how the applications are working in manufacturing, either in the direct digital manufacturing of in-use parts or for jigs and fixtures. So for all of the skeptics and visionaries, and for everyone that falls between, I strongly suggest that if you're not prepared to act, that you at least plan and strategize for your future with 3D printing, because the future of 3D printing, I believe, is infinite. The only limitation really is your imagination, the imagination of all of us here in the room. And I think 3D printing is making a difference in people's lives. It's everywhere, and as it continues to grow, and it'll continue its fast adoption. So, as I said, I've been part of the industry for 25 years, and I believe the next 25 years will be even more exciting and impactful. Thank you very much.